నేను అక్కడ హోస్ట్ చేసుకుంటే సరిపోయండి. హోమ్ హోస్ట్ అక్కడికి వెళ్తాను. నేను అక్కడికి వెళ్తాను. ఇక్కడ నుంచి హోమ్ హోస్ట్ చేస్తాను.
ఇప్పుడు ఇలాగా మీరు ఫస్ట్ ఇక్కడ నుంచి సీఎం పనిచేస్తారు ఈ పాయింట్స్ ఈ పాయింట్ సీఎం చేసి ఒక ఫిక్స్డ్ యాంప్లిట్యూడ్ మెయింటైన్ చేసి సెట్ చేస్తున్నాం ఫిక్స్డ్ యాంప్లిట్యూడ్ సెట్ చేస్తున్నాం అలాగే మీకు ఒక ఫిక్స్డ్ ఫ్రీక్వెన్సీ సెట్ చేస్తున్నాం 1000 ఆ తర్వాత సెట్ చేసిన తర్వాత ఓకే
Morning, sir.
Dr. BK Srinivasarao garu, good morning andi.
Yeah, good morning, sir. Very good morning. How are you, sir?
Fine, sir. Fine. Okay.
Yeah.
A very good morning to all the participants. Today we are at fifth day, the important day also for fifth day. So all the participants, they're very enthusiastic and very interesting. They're listening all the sessions. But today is a very special fifth day. So this is a valedictory day also. So in this, the valedictory will begins at 3:30 p.m. So today there is a 3 links we are giving. The first link for today's attendance, the second link for oral feedback, third link for test, today's test. The test will take place after completion of valedictory session immediately. Okay, so the test consists of 20 questions, all multiple choice questions only. So we are giving a 30 minutes time. We are giving a 30 minutes time. But please remember one thing. So once you press the submit button, so then you can view your score. You cannot alter the answers. Okay, so before submitting the button, you think all the combinations. Okay, once you press the submit button, then marks will be recorded. as it is, that will be shown in your response sheet quickly. Right? So, on behalf of organizing, I welcome Dr. B.K. Srinivasarao Garu. And now I request Mr. B. Vamsi Krishna, Assistant Professor of Department of ECE, Technical Engineering College. Please introduce the today's speaker.
Thank you, sir. Good morning to all. I am Vamsi Krishna, Assistant Professor in ECE Department, Goodwell Engineering College. I am proud and privileged to read out the profile of today's first session speaker, Dr. Kota Nagasrinivasarao Bhatta. Dr. Srinivasarao received master's degree from IIT Kharagpur in 2008 and PhD degree from IIT Kharagpur in 2017. Dr. Srinivasarao have a total of 11 years experience. Currently, he is working as assistant professor in National Institute of Technology, Warangal. His research interest includes VLSI architectures for image and video compression and design of embedded systems. He published more than 25 papers in international journals and conferences, and he is a member of IEEE and IE India. Dr. Srinivasarao received 22.5 lakhs grant for the project titled Programmable Electronic Jacquard Machine for Complex Designs in Handloom Sector from SERB Government of India. With these brief introductory words, now I request Dr. Srinivasarao to share his knowledgeable with us. I welcome you, sir. Thank you.
Viken Garu, initially you speak with video.
Yeah, okay.
Then onwards, you may switch on your video or off video. That is based on your interest.
Okay. So thank you for the extensive introduction. So first of all, I'm very much thankful to the organizer, the Professor M. Kamaraj Garu and my group. And after a long time, I'm able to see all my colleagues in Goodwell Engineering College. So that privilege is given by our Professor Kamaraj. And so coming to the guest lecture, actually now everybody is, the buzzword is artificial intelligence, deep learning, machine learning, or IoT. So these are the buzzwords. Why we have to move on to this particular new technology. Whatever may be the technology comes into the current era, so this is mostly for the feasibility of the human being. So to provide more and more flexibility and the autonomous. Everybody is looking previously when you go for a car, we wanted to learn the car with all the gears. Now the people are not interested to go for the gear car. Everybody is looking for automatic gear. So once the person is shifted to the automatic gear, it is again difficult to come back the gearing and all. So that is the one flexibility, means the advancement in the technology has given a flexibility for the users. And the next advancement is autonomous car. So how the autonomous car, the Tesla, recently Tesla Model 3, I've seen one of my nephew is using that car, and recently he has sent one video to me that is a very narrow place is there, means a parking place is very narrow, and he has given an instruction just through using remote or his, I think his mobile itself. He is controlling the car. Just he has given an instruction like the park the car. It's automatically it has taken a decision. Means the moon to and fro, and finally it was parked. So that means that much the flexibility is there with the technology, improvement in the technology. So now behind this automatic car, there is a lot of IoT components out there. There is a lot of sensors. So it has it is running with the Tesla M3 Model 3 is running with 128 processors, and it has 360 degrees of sensors. But So if you have a 360 degrees of sensors, each sensor is sending a huge amount of data. If you have a huge amount of computation facility, then it may be okay. So we can process it. But is there any possibility to reduce the computational complexity? So only we have to reduce the data, or we have to compress the data. How can you reduce, or how can you compress? Means we have to predict. So what should be happen in previous based on the already existing situations. So this means it's almost the predicting the situation based on the current scenario is nothing but a machine learning. From where the data is coming from the sensors. How the data sensors are working through IoT. Right? So that means there is a strong relation between the IoT and the machine learning. So because of this strong relation, I have observed the recent days. So, as trying to give a small guest lecture on this, a combination of machine learning and IoT. Right? Okay, we'll slowly move on to our slides. Sir, is it visible? My screen?
Yes, proceed, sir. Please proceed, sir.
Yeah, okay. Right. Yeah, today's my topic is machine learning for IoT. So there are the two subjects. You can feel like this is machine learning is one subject and IoT is another subject. Here I will try to give the link between the machine learning and IoT. So I think if this is the last day of your the IoT training program, I think many of the people have given an extensive lecture about the IoT and its uses, protocols and all. So I'm not going to in depth of the protocols or the communication protocols of IoT and the computational facilities of the IoT and all. Just I wanted to give a brief the introduction about how you can link this machine learning with IoT and all. So emerging technologies in recent years and the major enhancement to internet protocols and computing systems. So, so this I think already you might be learn many things about the internet protocols and computing systems which are used for IoT applications in the last 4 days, I think. So have made means there is a lot of enhancement has made in internet protocols. There is always a revision has taking place to find the data with a low bandwidth and all. And the computing system, as you are observing that the day by day, due to VLSI scaling, so there is a huge amount of computation facility is coming through a even normal embedded processor system. And because of these two combinations, internet protocols is always refining and which are giving a better communication, and the computing systems which are having more and more computation facilities. So these two made the communication between the different devices easier than ever before. So according to the various forecasts, around 30 to 60 billion devices are expected to be connected to the internet by 2020. So you see this number, 30 to 60 billion devices. It's a very almost the 60 to 70% of the devices which are existing in the world comes into the internet IoT era, communicate by using this IoT and all. So this has given a rise to newly developed concept of So because this number is not a smaller number, because of this requirement has made the feasibility or the requirement to develop the internet protocols and computing systems. IoT is a combination of embedded technologies, including the wired and wireless communication, sensors, actuator devices, and the physical objects connected to the internet. It means all these are connected through an internet. It's almost maybe they are physically dispersed in places, but through internet, all these are connected and communicate. So what is the machine learning? So the machine learning delivers the insights hidden in IoT data for rapid automated responses. So which insight means it will be looking to the hidden in IoT data. So what type of data? So that will be different for the different types of the use cases which are using. So it insights the hidden in IoT data for rapid automated responses and improved decision making. Why you use machine learning for IoT? So what is the need? The machine learning can help the demystifying the hidden patterns in IoT data by analyzing. So because now the data is a massive in trillions of terabytes, we are getting the data now. So to analyze the massive volumes of this data using sophisticated algorithms. So analyzing by using a human intervention is very difficult now. So if it is a small volume of data, then we may do somewhat, but now it is a trillions of terabytes. So it's very difficult to analyze the massive data. So then we have to go for the automation, or we have to go for some algorithms which can analyze this massive data. So which algorithms we have? We have different algorithms in the machine learning which analyzes or which insights the data and which detects the hidden patterns. So there your machine learning algorithms must be required. Since IoT is producing a massive amount of data, to analyze or to go into the in-depth patterns which are existing in the data, we must use some machine learning algorithms. The simple use cases. The companies are utilizing machine learning for IoT to perform the predictive capabilities on a wide variety of use cases that enable business to gain new insights and advanced automation capabilities. So for a small example, the power distribution companies, suppose in AP we have a lot of power distribution companies are there. They're there in the power station. So how they will estimate the data for the future? So that estimation will be generally happen. Suppose how much amount of the electricity will be going to consume by today. So that should be estimated well before. Otherwise, they cannot generate that amount of the power. How it is possible? Based on the previous history, maybe in the previous day and the previous day in the last year, or in the previous month, or maybe based on our summer, winter, based on the different weather conditions and all. So all the conditions have been considered, and the machine learning algorithm will predict what will be the expected consumption by today. Like that, not only in the power sector, you can go for in the business or in the share market. So we wanted to be expert, or we wanted to predict some information based on the previous history information. How it will be performed only by using machine learning algorithms. So with machine learning for IoT, you can ingest and transform data into a consistent format, because we have a massive value of data. We should format, or we should arrange in a particular way. So that can be done by using machine learning, and build a machine model and deploy this machine learning model on cloud or edge and the devices, even in the devices itself. You can deploy this one so that it will analyze the data, and that particular, whatever the small information which is required from the analysis, only that particular information will be sent to the devices, so that it need not to send the massive or the communication may be reduced, means the communication data may be reduced between the devices, or from the edge to devices or cloud to devices and all, because it analyzes the data and the features only it will be sent. Based on the particular features you can analyze or you can expect the data. So for example, using machine learning, a company can automate the quality inspection and defect tracking. So on a conveyor belt, suppose if items are moving, then by using X-ray, we can detect if is there any fault inside this particular device and all. So like that means automation, the quality inspection and detect tracking on assembly line. Track the activity of assets in the field, activities of the assets in the field, and forecast consumption. The forecast consumption, just like the previous example, power consumption, like, and demand patterns, means what will be the demand in coming years or coming days, like that we can expect. So the main objectives to understand which algorithm is more appropriate for the processing and decision making on smart data. Means smart data is nothing but the data which is come from the IoT devices, generated from the thing in the IoT, which is essential to consider the following three concepts. One is, so what type of IoT application and what type of data characteristics is having, what is the characteristics of this smart data, and the data-driven vision of machine learning algorithm is based on the characteristics which machine learning can drive this particular data and so the next coming slides, I will give you the complete details for which application we can use the which algorithm. So this is the model linking for ML and IoT. So the smart data or the Internet of Things means this is, you can expect to be, it is a data is the or a raw data. It's a raw data. So the data is the motivation, means we need to analyze something. So maybe use cases means the data maybe come from the smart city or smart city data. So what type of the data we can exist or that comes from the smart city. So one is the smart energy, smart traffic control, autonomous cars, or automatic street light, or usage of the water, drinking water, and all means data wherever the requirement is, or from the sensor, means even from the traffic sensors or GPS data or the smart energy. The smart city has all these different types of applications. All the applications will send the data. So then based on this particular data, if we take a small example of smart city, so it has different varieties of the functions. Each function may have different characteristics of data. The sensors or the devices which can send the different amounts of data in a different characteristics. So the taxonomy of machine learning algorithm, the taxonomy of machine learning algorithm indicates if the data characteristics are having a requirement is prediction, then which algorithm is required for that type of data. And if you require a classification, then what type of the algorithms we need to use. So the taxonomy of machine learning algorithms will give you that based on the data characteristics, which algorithm is more suitable and applicable. And then you can design, means based on the output given by this machine learning algorithm, so that you can take the decisions. So the procedure, the data mining, the first one is a data mining on IoT data involves three major concerns. Yes. Now, to mine the data, So we require at least of these three major concerns. So the first, it must be shown that processing the data will solve the chosen problem. After processing the data, it should solve a chosen problem. Data characteristic must be extracted from the generated data, and appropriate algorithm is chosen according to the taxonomy of algorithm. The purpose of the Internet of Things is to, so it is a general thing I am giving. The purpose of Internet of Things is to develop a smarter environment and simplified lifestyle by saving time, energy, and money. So we are now almost everybody is busy with the work. Means we should save the time for each and every activity. So the major goal of this Internet of Things is saving the time, saving the energy, and saving the money. So these are the main parameters behind the working of this IoT device. Through this technology, expenses in different industries can be reduced. Because if you do the automation, then majority of the cost is going to be reduced. And the enormous investment and many studies running on IoT have made IoT a growing trend in the recent years. IoT consists of a set of connected devices, that can transfer data. So this set of connected devices, based on the device, the data characteristics will be defined. So one another, the data among one another in order to optimize their performance. Is why you have to receive the data to optimize the performance. So these actions occur automatically and without awareness of the human or the human input. It includes, IoT generally includes the sensors, which will send the data, and the processing network. After sending the data, we need to process that particular data, and after processing the data, we need to analyze or extract the things from that and system monitor. Based on that analysis, the system may be controlled or monitored. The most recent advancements made in IoT began when RFID tags were put into use, and lower cost sensors became more available. Even this is also one reason grown in the IoT, lower cost sensors. Previously, the cost of the sensors are very high. Now, the CMOS sensors, many of the applications, the users, the designers have designed the CMOS sensors, which reduces the cost. So lower cost sensors became more available. The web technology developed. So previously, we have the internet IPv4. Now we are using most of the industries and the academic institutions are using the IPv6 protocol, and the bandwidth also previously in terms of megabits, now it is in terms of gigabits. Previously Cat5 cable we have used for transfer of data. Now we are using Cat6 cable. So that means the bandwidth has increased, and many of the cases, many of the towns and all, the media backbone is the fiber optic media. So completely the technology is changing because the data usage has increased. So to capable of that much the data requirements, so only the way is not the copper wires, only the fiber optic cable. That's why many of the industries have changed the wired cables with the fiber optics. The IoT is integrated with various technologies, and connectivity is necessary and sufficient conditions for it to function. So therefore, the communication protocols are consistently constituent of this technology that should be enhanced. Already, the many researches are taking place on this one, communication protocol, is the communication protocols for IoT applications. Still, there are a lot of researchers doing research on this particular area. So take because in our entire presentation, we are saying that based on the data characteristics, data and algorithms, machine learning algorithms. So for understanding which type of algorithm we need to use, for that we must know that what type of data is produced by IoT. So for that, I have taken a small example of use case smart city. So in a smart city environment, what type of data will come and how to analyze this particular data by using our algorithms. The city is always demanding a service to enhance quality of life and making existing services more and more efficient. In the last few years, the concept of small cities has played an important role with the funds given by the central government. Many of the cities are now becoming a smart city. Even where I'm working, Warangal is also a one smart city. We are also working with the municipal corporation of Warangal, so to do the more and more things to be smart. One thing we have recently done is so automation in the traffic. In some areas, the automatic the traffic and that particularly every traffic light near to every traffic light we have arranged a camera so that automatically it captures the density of the lane, means the traffic density of the traffic on that particular lane. Automatically based on that particular the density, the time allocation for the green light in that particular lane is going to be varied. If the density is very less, then the time to allow the traffic is going to be reduced like that. So that is also one application in the traffic, means automatic traffic control. And with an increase in population and complexity of city infrastructures, the cities seek methods to handle large scale urbanization problems. So automatically the people increase in the cities. So always they are going, always they wanted to see the advancements. So that will be available in the cities. That's why the population is increasing. So IoT plays a vital role in collecting data from the city environments, where the density population of the density of the population is increasing. So based on that, we can take the decisions. So always we have to monitor how the population is increasing in the city infrastructure wise. So based on that, some people will get benefit in the realtors. Generally, they can estimate or they can predict. So this is the area which will be booming up or increasing, the population increasing rapidly, so that they will investment there. So IoT enables cities to use live status reports and smart monitoring systems. They react more intelligently to emerging situations such as earthquakes and volcanoes. We can explain from based on the weather forecasting, and by using some algorithms, we can predict whether is there any possibility of earthquakes and volcano eruptions. The smart city, by adopting IoT technology in cities, the majority of the city's assets can be connected one another, making them more readily observable. So this is the good advantage. So many of the assets can be connected one another with internet, making them more readily observable and consequently more easy to monitor and manage. So from one place, we can manage or we can visualize each and every aspect in the city. So that from the control room, and we can manage it from there itself. The purpose of building the smart cities is to improve the fund. Yeah, sorry for this one. So the purpose of building smart cities is to improve services like traffic management, water management. So the traffic management is the one requirement, and water management is another requirement. We have to reduce the water wastage and energy consumption, as well as improving the quality of life for the citizens. So the objective of smart cities is to transform the rural and urban areas into places of democratic innovation. Such smart cities seek to decrease the expenses in public health, safety, transportation, and resource management, thus assisting their economies. We have to take care of, for the smart city is concerned, we should manage the traffic and water management and energy consumption as well as the quality of life. So that means each and every moment, means the traffic light, means all the traffic signals should be connected through IoT and it should be automated, right? And water management, everywhere we have to see that the wastage should be reduced, water wastage should be reduced, and energy consumption, how the energy is consuming. Based on that, how we can generate or we can estimate the coming days consumption and all. So as well as improving the quality of life. Yeah. No, I think it is not required. Yeah. The smart city devices generated data in a continuous manner. Means any of those objectives concerned, whether it's water management. Means water management means we have to install the large number of the sensors at a different places, so that we have to capture the data continuously. Is there any other water wastage or water leakage? So we can observe from that one. Like that, the traffic lights or traffic control is always connected or sending the data. So by using a camera at the traffic places, so from that we can estimate whether we need to increase the road widening or the wide or any other the actions we can take based on the data which we collect. And health and gather from the traffic, health and energy management applications would generate a sizable volume. Means all these sensors, so basically we can say that it's the sensors. All these sensors will generate a sizable volume of data. In addition, because of data generation rate varies for the different devices, processing data with a different generation rate is also a challenging task. For example, a frequency of GPS sensors is high. Every second, we need to capture the data in GPS sensor. While the frequency of updates of the temperature sensor may not be that much, maybe even hours is also sufficient. Whether the data generation rate is high or low, there always exists a danger of losing important information. Yes? If you increase the frequency, then you are collecting a huge amount of data. If you decrease the frequency, then there may be a loss of some information. Important information may be lost. So we have to optimally select the periodicity of the data collection. To integrate the sensor data collected from the heterogeneous sources is challenging, because the data come from the GPS sensor and data come from the temperature sensor is not having the same characteristics. These two different devices and characteristics of the data is also different. The sensory data collected from the heterogeneous sources is challenging. Another characteristic is dynamic nature of the data. The data is also a dynamic nature. It will be varied with respect to time. Data for autonomous cars is an example of dynamic data, because sensor results will change based on the different locations and time. When the car is moving, based on the locations and times, so automatically the data is dynamically changing. So the quality of collected data is important, particularly for smart city data, which have different qualities due to the fact that they are generated from the heterogeneous sources. The quality of information from each data scores depends on three factors generally. So the quality of information is the main parameter now. So how it will be varied, or in which parameters it will be going to be depends. One is error in measurements or the precision of data collection. So for more quality, we should reduce the errors, device noise in the environment, because it is a real-time environment. So we are collecting the data in the real time, so that there will be a noise based on the environment and discrete observations and measurements with the different time slots we are observing. So that based on all these three parameters, there will be the quality of information may be varied. So the quality of information is the main goal for better performance of IoT. To achieve better quality of information, it is necessary to extract higher levels of abstraction and provide actionable information to other services. QI is smart data depends on application and characteristic of the solution to improve. So what is the solution to improve quality of information? To improve the accuracy of data, selecting trustworthy sources, we need to select only the trustworthy sources, and combining the data from multiple resources is of key importance, because we are collecting with the different places and different sources. So that is also very important for improving. We have to select the trustworthy sources, so that that will give you the better results. By increasing the frequency and the density of sampling, the precision of observation and measurements will be improved. Okay? So by increasing the frequency, definitely the quality of information is going to be improved. But what is the problem? Which will increase the data. Means instead of taking the hourly samples, if you take in terms of minutes, then the data which is received by the processor is very high, which would lead to a reduction in environmental noise. Maybe if you take a more and more number of samples, it will lead to a environmental noise may be reduced, but the data we need to manage. How we can manage that data? Achieving QI, the semantic data annotation is the other prime solution to enhance the data quality. So semantic data representation. The smart devices generate raw data with low-level abstraction. For this reason, semantic models provide interpretable descriptions of data, it is quality and the original attribute. Semantic annotation is beneficial in interpretable and knowledge-based information fusion. Means we can convert this raw data into the semantic data annotations. Based on this data, we can represent in a data semantic notation. So for that particular means, to achieve the quality of information, better quality of information, so we must be denote in the form of raw data must be denoted in the form of semantic annotation. The machine learning is a subfield of computer science and is a typical artificial intelligence that provides machines with the ability to learn without any explicit program. Machine learning evolved from the pattern recognition and computational learning field. Machine learnings are more suitable for smart data analysis. This is the point where the IoT and machine learning are flourishing. The machine learning takes a set of samples as the input named as a training set. In general, there exist three main categories of learning. One is supervised learning, unsupervised learning, and reinforcement learning. In an informal sense, in supervised learning, the training set consisting of samples input vectors together with their corresponding appropriate data vectors, also known as the labels. Means first at the time of training, so there should be a data and a corresponding labels also will be mentioned. So by analyzing the data characteristics, later it will identify the labels which are not having any labels. In the unsupervised learning, no labels are required for the training set. Reinforcement learning deals with the problem of learning appropriate action or sequence of actions to be taken. So this is mostly useful for the robotics. So to understand how these particular algorithms are going to be worked, or if the data captured, if our characteristics are changing, then which type of algorithms we need to use. So for that, just I have taken a small example. Suppose, because IoT or the technology is giving that automation. Automation is the key point behind the IoT. It's without any intervention of the human being. Here, I have taken a small example. I'm not going to the very complicated example. I have taken a small example. So the example means objective is to suppose that a fish packing plant, here is a company, okay, wants to automate the process of sorting the incoming fish on a conveyor belt. This is so based on the physics is the sample. So our objective is, or the company objective is to automate the process of sorting. And so there they wanted to remove the human intervention and automatically wanted to be packed. So a pilot project, I decided to try a separate sea bass is the one type of fish and the salmon is the another type of fish. Means they wanted to separate this sea bass and salmon fish using this optical sensor. Means while designing the automation system, the first they have taken these two types of fishes. Here you can see the model or shape of the salmon fish is this one and the sea bass is like this. Means generally the sea bass are more in size and compared to the salmon. So then how to design this system? Now you feel like you are going to design this particular system. So the project model, we set up a camera, take some sample images and begin to note some physical differences between the two types of fish. So what are the physical differences, or what are what are the features, different physical features or physical differences between the two types of the fishes? So what are the physical differences? One is the length of the fish. Another may be a lightness, means the color of the fish, means the width of the fish, number of shapes of the fins. You see here the fins. So it's like this, but it is having like this. Shape of the fins, the position of the mouth, and so on. These are the different the physical differences between the sea bass and the salmon. We also notice the noise or variations in the images. Maybe with the different one thing. So always, if you are designing a system, maybe in horizontal direction, in this particular direction, you can take, or you can identify here. This is the position of the teeth or the head, and this is the position of the tail, and the fins will be like this. So then now we can segment, or based on the shape of this head and all, then you can decide. Suppose if on a conveyor belt, you cannot expect that all the fishes will be coming in this particular direction. It may become like this, or it may become like that in this particular direction. Means in different directions that the fishes may come. And one more thing is not only the direction and the size. Different sizes of fishes will be available generally. And one more thing, the lighting position. Suppose in the morning time there will be a huge amount of light will be there. In the evening time there will be less amount of lighting. This lighting noises, maybe variations in lighting is also gives you the lightness variations. Means physical light variations means the light intensity variations may cause lightness of the fish. So the variation in lighting position of the fish and the conveyor belt even static due to the electronics of camera itself. Suppose the fishes are arrived like this on the conveyor belt. Okay, so this is one fish and this is another fish, and we have one other fish like this. So how to process it? So generally you may think like, yeah, we can process meat without human intervention. Generally, how the people will differentiate the fishes based on its characteristics, that is physical characteristics. Then they can observe. But now we wanted to do automation. So the human eye generally replaced with the camera, right? You assume that here there is a camera is fixed on a stand, and this is your conveyor belt. The fishes are comes like this. So first, we should mean the position of the fish. Maybe it will be comes like in this particular position, or it will come. So we have to arrange, means first we have to identify the fish and we have to segment it, and then so it should be arranged in a right direction. Okay, and then we have to identify what type of the head it is having, how many number of fins are having, what is the color of this fish, and all. So first we have to do the pre-processing. Means after capturing the image by using your camera, then we have to pre-process it. What is pre-processing means? We need to arrange in a particular direction by observing the segmentation and all. By applying the segmentation and all, we have to rotate it by using a rotation algorithm. In a proper direction, we have to rotate it. Means we should keep the fish in a particular direction. That we call as a pre-processing. And then extract the features. Means how much size we have. It has a head. And what is the color of this one? What is the length of this one? Means extracting the features. And then based on the features that extracted, we need to classify. Okay. So we have many machine learning algorithms, many image processing algorithms are available for pre-processing of the image. So you just assume that by using the pre-processing, we have eliminated these things. Okay, so we have eliminated this one. We have only this particular fish. Okay, now we have to extract the features of this fish. So then now, what are the physical features? One is, what is the length of this one? Suppose I observe that it is a 50 centimeters or 60 centimeters. What is the width of this one? And what is the lightness intensity? So that means these characters means how many fins are it is, and what is the shape of the fin, or what is the shape of the tail. So features, we have extracted some of the features, right? And then how to classify whether it is sea bass or a salmon? Then we have to consider, means when you observe, means suppose when you take a input from the previously worked person, now we wanted to remove that particular person, and then we have to automate. If you ask the previous information, which will be useful for identifying the fish right now, that feature information we can call it as a trained information, because previously the persons have worked on this particular task. Now we have removed that particular. If you take some information from that person, he will tell you that generally the sea bass are more in length, and the color is generally it is more white or more black like that. The fins will be, it has a more number of fins, and scales of the fish are generally more, or the size is more for the sea bass and it's less for the salmon. Like that, they will give you some information. Okay. So now based on their information, suppose the first one is, they said like the size of the sea bass is more, length is more. Then based on the length, which is having more, then we can say that it is a sea bass. May not be 100% correct, but it's some input, past input we take like that. Okay, some features, based on some features, we can classify whether it is a salmon fish or the sea bass. Right? Now we are going to how to extract the features, or whether the features which you have extracted is sufficient to classify it or not. Yeah. The first, the camera captures based on the project model. We have designed such way that the person has remote, his eyes are replaced with the camera. The next, the camera pre-signals are processed to simplify subsequent operations without losing the relevant processing. The pre-processing information has been done. And then segmentation. The images of different fishes are somehow isolated from one another, and then the the background is also isolated. Now the fishes are ready. So then we have to extract the feature. The information from a single fish is sent to a feature extractor whose purpose is to reduce the data by measuring certain features or the properties. The features are more precisely the values of these features are then passed to a classifier, and then the classifier will decide. So this is the different sequences of operations to perform to separate the salmon and sea bass. So how the feature extraction means, somehow by using image processing algorithms, you have done the pre-processing. Now the fishes are available, means you just see after segmentation, the somehow isolated from one another, and then the background information is also clear. Now it is given to a feature extraction. Now the feature extraction, the sea bass is generally longer than the salmon. Means this particular input we have taken from the person who has worked previously, or from the data which you have observed in the land. Okay. Now, our tentative model for the fish is sea bass have some typical length, and this is greater than a star. Generally, so the sea bass is generally more length compared to salmon. Then you should identify the length. Which length means typical length? We call it as that typical length. If the length is less than the typical length, then we can call it as it's a salmon. It's a salmon. Or if the length is more than this typical length, so that we call it as a L star. That we call it as a sea bass. Okay. How to identify this typical length? That should be happened based on the previous data, previously collected information. So our tentative model is identify the typical length. The length becomes an obvious feature, and we might attempt to classify the fish merely by seeing whether or not length L star of a fish exceeds from the critical value. Sorry, here not L star, this is L. This is L star. Critical value means L star. Choose L. We could obtain some design or training samples of different types of fishes, somehow make length measurement and inspect the result. Suppose if you measure the length of the fish, here when you see the salmon fish and the sea bass, suppose L star is like this, means 15 centimeters is the critical length. The fish which is having less than 15 centimeters will be identified or classified as salmon, and which is having more than L star will be identified as a sea bass. Okay, so this block color is indicate the salmon. In general, based on the human observations, this is salmon, and this red color indicates it's the sea bass. Okay, that is with the feature, previous information, based on the previous information, it is like this. Now, if you observe the length of the sea bass and length of the salmon, it comes like that. Okay, means the sea bass fishes which are having less age may have length less than L star, and like that, the salmon fishes which are having higher age may have more in length, which will become under this particular position. But if you decide or if you classify the system only based on the length, then this will be the error. Means this red color actually it is a sea bass, but your classifier based on only length. Based on only length, if you classify it, your classifier will classify that the sea bass as a salmon. Here, which is having a more length, the salmon fish has a more length will be identified as a sea bass. So that means this red color in before 15 centimeters identified as error, and block color after the L star is identified as error. Means your system is identifying this block color as your sea bass because length is more. Though it is a salmon fish, but it is identified as a sea bass. That is the error. If you depend only on the one particular feature, then there is a possibility of error, more possibility of error. So this disappointing histogram based on the statement of sea bass are somewhat longer than salmon on average, but it is clear that integrity is quite poor. No matter how we choose L, we cannot reliably separate the sea bass from salmon only by length alone. Then how to reduce the error? What is the different possibilities? We have to go for some other features also. We should try another feature. Another feature is average lightness of the fish scale. Now we very carefully eliminate, because only we are dependent on the lightness. Lightness means we should take care of external lightness variation should be minimized, or always we have to maintain a constant amount of illumination or the light, because these variations in the lightness, external light variations may cause the error. Okay. Now you see different the salmon fishes based on the lightness index, means color based on this color. Now using that, suppose if the lightness intensity is extra, means illumination is that lumens, X lumens. If the illumination is less than X lumens, then it will be identified as a salmon, and it's greater than that, then it will be identified as a sea bass. Though the length variations are occurred, generally the fish scales are automatically have the almost the same. Right? Even it is a small fish or a big fish, the color generally varies very small amount, not a drastical variation. So if you use only the lightness intensity, then this is the error phase. So that means this red color it indicates actually it is a sea bass, but having the colorless. And this is the salmon fish which is having more white color. So that only the error is this one. When you observe the previous histogram and this histogram, the error is reduced, right? Error is reduced. Then why can't we add? Why can't we add the two features to separate? Two features are to separate the salmon array to use for classification purpose. Okay. Now you see, by taking both length, instead of length of they have considered the width and the lightness. Maybe even you can take the length also here. So the two features are considered, and these red dots will indicate means the lightness and the length. So this will indicate the sea bass. Generally it has a more light, and generally it has more width also, so that we can separate lengthwise and lightness wise. So there is a separation line can be identified, so which will reduce. This line should always design switch that in such way that it should produce less error. Okay. So when compared to previous two conditions or two models, one is based on the length and another one is based on the lightness intensity. Compared to those two, this will provide you a less error or more classifier, which will be more efficiently classifying the sea bass and salmon. Like this, if you can introduce some other features, means the feature extractor can take or can extract the sum of the features. Here we have identified two features. Not only two, you can take more and more number of features to separate it. And at the same time, even after considering the different features, you should very careful for designing of the separator, this separator. So if you can design more efficient way of designing this separator, suppose it is designed such way that it is like this. Any equation or any system which is designed in this particular way, then definitely we can 100% achievement. We achieved 100% the separation of C dash with Solomon. But which system will design in such way that in such fashion? Okay. Now we have to more care about. We have to take more care about how we can separate or how can we classify. This is line is a classifier. How to design this classifier based on the features. So that is now the most of the machine learning algorithms is depends on this particular thing. Which algorithms which gives you the more and more appropriate the classifiers that we call as the best algorithm. Now you see here, so overly complex methods means some complex methods we can design. So overly complex models for the fish will lead to decision boundaries are complicated, while such decision may lead to a perfect classification of our kind. This classification model may give you a better result, but what is the complexity of this classification model? Is it a two-dimensionality or three-dimensionality or four-dimensionality system? We have to go for multi-dimensionality system. And it leads to a poor performance on feature, the patterns. Even if we take this one, here suppose this is color, means it is identified, means the question mark indicates that suppose this is a sample of salmon, means it is belongs to this one. It's a sample of salmon, a sample of salmon. But your classifier, though you have designed a very complex system to classify it, there is a possibility of giving error output. Maybe error is less, but there is a possibility of still even very complex model also may classify errorly or differently than existing. So is evidently most likely a salmon, whereas suppose this is a salmon, likely be salmon, whereas the complexification boundary shown leads to be mislead and it's shown like a sea bass. Then previous one, when you observe that this, suppose previous line is taken. This is the one, a simple classifier, means line equation is sufficient to classify the system. But what is the problem with this one? Which you call as a linear model. Right? This classifier is a simple to design, is a line equation only, but the error is more, right? So here, if you see that there is a more error in simple classifier, less error in complex classifier. Then which one has to choose? Whether we have to go for this one or whether we have to go for this one. That is again a trade-off. Always it is a trade-off. Complex versus simple. Complex versus simple means complex system will give you less error and the simple system will give you the more error. Right? Suppose via media, it is a trade-off between optimal, a trade-off between a complex and error. if you design a system in such a way that this one, previously a linear one, now it is a non-linear system. Though it is a non-linear, order may be second order. So this system will give you the somewhat less error compared with the linear system, right? When you go for this linear gives you the more error. When compared to this linear model, non-linear model will give you the more accurate result or less error. Whereas when you go for complex system like this, something like this, then this will give you the very less error. So we have to mean as a designer, we must take care of, or we must be a trade-off. Always it's a trade-off between performance and the complexity. Optimal way if you can take, then this nonlinear classifier may give you the better result compared to simple. Means complexity wise means maybe error is less compared with the simple classifier. Error is more compared with the very complex classifier. But complexity wise, more complex compared to linear and less complex compared to the complex models. So that is a trade-off. Means non-linear or second order design, second order filter or second order classifier generally gives you a better result or a better performance. In the broader sense, any method that incorporates information from training samples in the design of a classifier applies the learning. So this learning method is very crucial sort of thing for designing the classifier. Because nearly all practical or interesting pattern recognition problems are so hard that we cannot guess classification decision ahead of time. So we shall spend a great majority of our time for considering the learning. Learning is more appropriate and important. Creating classifiers then involves posit some general form of model or form of the classifier and using training patterns to learn estimate the unknown parameters of the model. Okay? So these are the requirements. And learning refers to some form of algorithm for reducing the error on a set of training data. Yeah. So what type of machine learning algorithms we have? The types of machine learning algorithms. The machine learning algorithms can be classified into three types: the supervised, unsupervised, and reinforcement learning. The types of machine learning here: reinforcement. Machine learns on its own in the reinforcement learning. Unsupervised learning, actually, we cannot say like no training data is required. Here, training data without labels. And here, the machine learns from the training data with the labels. Okay. Yeah. So these are the different algorithms: the supervised learning, unsupervised learning, and reinforcement learning, where it is used. So supervised learning basically more suitable for the classification model. So which will be the fraud detection, email spam detection, diagnostics, image classification. A particular output is required, then better we have to go for classifier. Classifier model is generally better implemented by using supervised learning. And the regression, so risk assessment and score prediction, this is also can be done by using this one. And coming to unsupervised learning, dimensionality reduction, the text mining, face recognition. Here face recognized, but whose face it is means giving the output is again difficult. That will not be done by using unsupervised. That should be image classifier, can be done by using supervised learning. And big data visualization, image recognition. The clustering, biology, city planning, targeted marketing. And reinforcement learning, gaming. So these are the different applications. Means which algorithm is more suitable for the application. Gaming applications, you have to go for reinforcement learning. Finance sector, go for reinforcement. inventory management, robot navigation, everything. Everywhere we have to go for reinforcement. The reinforcement learning means by itself it is going to be learned without any training data. Based on the situations, it will take the decision. Right. The first we'll go for supervised learning. Supervised learning, as the name suggests, getting supervised by someone. It's always supervised learning means it is someone will take the means to take the decision. He will be supervised. So that means timing is always required here. It is learning in which the machine uses data which is already targeted with the correct answer. During learning phase, it will learn that. So based on the image, input image, it will extract the sum of the features. These features is targeted to the output. Means if the color is violet color and the shape is in this particular form, then we can, during training, these features will be for base. It assigns or it learns, and then banana. So based on its shape or feature, length and shape of this feature, then it will be identified as banana. During training phase, it will make a table. These are the features. The output is this one. Means it will, the features are labeled to someone or it can categorize. After learning is completed, if after learning is completed, suppose you have given a input is this one. Training is over. Then first it extracts the some features. If the features means color is one and shape is this. These features are corresponding to already because it has made a table. These features are belongs to the grade. Means it gives you the output as grade. So that is called as supervised learning. That is called as supervised. Next, unsupervised learning. So in the unsupervised learning, the training of the machine is done using the information which is neither classified or not labeled. Means the output is not labeled. Means first it will extract the features. Based on the features, maybe it will give to group 1. These features are belongs to group 1 or cluster 1 and some other features. So these features are may belongs to the category 2 or cluster 2. It doesn't know what type of object it is. If the characteristics are similar, then it will be assigned to or it will be identified as the clusters or the objects. You see here, previously we have given suppose the pen and pencil. Okay, so means pen and pencil means the pencil is shape is like this and pen is like this, something like this. Here, this is pen and pencil we have given. Okay, this is coming to category 1. Category 1. Okay, then we have now if I given a cap of a pen and a small stick, this will be the input now. Suppose. Then it will extract the features, and these features are similar to pen and pencil. Is it true or not? Because this stick is more similar to this one, and this cap is more similar to this one. So that because doesn't know means it has not given any names of that one. We are feeling like category 1 is pen and pencil. So that just if you give this as your input, then automatically it will extract some features. These features are more similar to the category 1, so that it will give you that category 1. Maybe for category 1, you can label it as that pen and pencil or something like that. But it don't know what type of object perfectly it is. But if you require this is a stick or this is a cap like that, then definitely you have to go for supervised learning, not for the unsupervised learning. Means if you want to cluster a group of objects which are having a similarity, then you have to go for unsupervised learning. And next one is the reinforcement learning. So reinforcement learning mostly used for embedded applications for robotic conduct. Based on observations and based on the environment, it will take the decision. Now going for the in-depth of the algorithms, the supervised learning and unsupervised learning. So just I'll give you a brief idea about the supervised learning so that you can estimate the unsupervised learning because it takes a lot of time. So just I'll give the details about the supervised learning and its algorithms. Yeah, supervised learning. The first will give the inputs, means these are called as the training set. This training set, from the training set, automatically your system, machine learning system will extract the features. You just like take a grapes, banana, and different types of fruits are there, and based on the each fruit type, it will extract the features, and based on the features, the labels are also provided in the training shape, the training itself. During the training, if the shape of an object is like this, then you label it as this one. You suppose take an example of grapes. If the color is violet color and shape is in a particular manner, then you can call it as based on that particular feature. During training, it will give you that it labeled it as grapes. Okay. And based on the banana, if you have to give different or large number of input sets so that it extracts the features. Based on the features, the classifier model will modify and use the labels also. Okay. Now after training session is completed, now if you give the new image or new info, then for that it will extract the features, and already your machine learning algorithm has formed a table. If these are the features, means based on these features, the output is designed. Suppose the features are similar to this one, first table 1 property, then that will be output is great. The second feature means features are belongs to second table, then that will be called as a banana, like this. Means based on already designed model, the classifier is designed. Based on that, it will predict model, will expected label will be given. Means based on your input, it will give you the output as grapes or bananas or something like that. Means perfect labeling is done here. During unsupervised learning, so the features are extracted. Maybe it will be formed like these are the features comes into one category, these are the features comes into another category, like that. So maybe length is this one. So if length is less than 1 meter, then it's the stick. Something like that. Not stick, it's a category 1. There is no perfect name, it's a category. Now if you give the new input based on the features which are extracted, then it will model maybe if the length is less than 1 meter, maybe it is a category 1. Then you can call it will be output is the one that is category 1 or category 2 like that. Now going for a small example for the supervised learning. Here the variables are attributes or features, something like that. These are the some features. Means these are the objects, different objects. Objects are a person. Is this object one is a person 1 samples. Means there may be this is a blood test result, or this is urine test result, or in the blood test, the different categories, different features of them. So these are the different samples we have also. Okay, different the samples are different features you have observed. These are the features of different person. Okay, this is the person 1, different features. Person 2, different features. Now, based on the features, the output means during training session, based on this output model, we have means supervised learning will design a system, means output Y, based on the existing one. Suppose the variable or a feature A1 is this one, A2 is this one, A3 is this one, A4 is this one. If all the features are like this, then we can say that he is a healthy person. If the features are like this, then he is a diseased person. Then based on this one and these features, we can estimate a model Y is a model of hypothesis of all the features A1, A2, A3, A4. The goal from the database, learning sample, find a function H. Our model, our aim is to design a model H, that is classified model. H are the inputs that appropriate at best the output. The symbolic output, classification problem or regression problem. Numerical output is the regression problem. Make predictions. So for a new sample, now this is during training session. Now we have designed such way that Y is a function of H, A1, A2, something like that. Means we have designed this model now based on the previous history. Now, if the samples or new features are like this, then what will be? Based on these particular features, already you have designed with that Y is disease, means we got the output is disease if A3 is equal to F and A2 is less than 0.3. A2 is less than 0.3. So then it is a disease. Means this will become, means based on all these based on all these values, we have trained or we identified that Y is equal to H is. Y is equal this one, disease. Y is equal to disease if A3 is equal to F and A2 is less than 1. If the new samples having this characteristic, your output is this one. Other than this, then your output is healthy. So it may be means different patients' observations. So we can use this one to treat the biomedical domain, the medical diagnosis, differentiation of diseases, the prediction of response of a treatment, or like that. Means for different samples, we can identify the system. We can estimate the output, whether the person, based on his features, we can estimate whether he is a healthy person or is a diseased person. Like that, we can identify the handwritten number. The first will talk handwritten character recognition. This is our task. We need to identify this. May be used for number plate detection. During the traffic, suppose if a person is going with a high speed, then we have to identify the number plate. How can you identify? Because each person, a different number plates will be there, or number notations is there. We have to identify, we have to extract the character. So by the time you can use this supervised learning. Okay. And some other example, like this is the time series prediction, predicting electricity load. This is the time, means suppose now we are at, this is the present time. Going to the previous data, this may be hours. This is in terms of hours. So this is the shape, means the average shape is inner, the solid block color is indicate average load. So based on your previous data, now we can estimate that what will be the next, the coming hours, means we can predict. So that based on the prediction, the power companies, means the power producing companies, will try to generate that particular amount of power. So the prediction based on the forecasting or prediction, here we can use the supervised learning. In this type of applications, we can use. Means the previous one is useful for the traffic control and density. And here this is also used for automatic power distribution. These two are some examples, data type and its characters. So these characteristics may be, generally we can say that it's smart city data characteristics. So if the data is in that particular manner, then we can go for the supervised learning. Even when you go for medical diagnosis, the two measurements here you can see, even in the supervised learning, what type of algorithm we need to use. So we have different algorithms. So already we observed that the model, classifier model, is a linear model or a non-linear model or a complex model. Whether if you go for this is, say that it's a linear model. Generally, the expression for this one is means this is your y. So this is if you see this one, this is linear multiplication of the weights. So these weights are going to be adjusted based on the training during training time. So what are the linear models we have? The perceptron, logistic regression, support vector machine, and the multi-layer perception. These are the general models in linear. Even so here these two we can call it as it's a linear model. This is for non-linear and this is complex model. These are the techniques used under supervised learning. Perceptron model, just like line, right? So this is the one classifier and this is the other classifier. Suppose go for some more complex, means compared with the linear model. Now if you have m1 square and m2 square, means second order equation is also existing, so that it is like parabolic sort of thing because it is a second order. So this is one type of classifier. And another classifier is this one. Here this classifier model is support vector machine is the one example for this model. And the third one is a complex model or a complex classifier. This is generally using artificial neural networks. This is the one example for artificial neural networks. The complexity of the system is increased. Now you see all three models. One is a linear model, is a logistic regression, and the quadratic model or the second order model. This is for SPM, and this is for the complex model, example of artificial neural networks. Based on requirements, we can select any one of the models. Yeah, some of the supervised learning. So they are KNN model, linear method, artificial neural networks, support vector machines, decision trees, and ensemble method. These are the different algorithms available in supervised learning. I'm not going to in-depth of this one. I have given already this PPT. Even now, by varying the number of neurons in the artificial neural network, you can change the count or you can change the classifier model. If only one neuron, then it will be work like a linear model. And if the 2 plus 2 neurons, then it will be work like a non-linear or the quadratic model. And if the number of neurons are increased, then it will be goes to the complex model. Means the complexity is increasing in this way. In same neural network with less number of neurons, it will be work like a linear model, and 2 plus 2 neurons will be work like a non-linear model. And if the number of neurons and the number of stages are increased, hidden layers are increased, automatically you see the complex model. Yeah, I'm not going in depth. Yeah. So coming to the taxonomy of machine learning, the supervised machine learning. So it has the different the types of the algorithms, supervised under supervised regression classifier, and so other coming to unsupervised machine learning, the clustering, feature extraction. Each and every one has its own models or algorithms. Now coming to the cheat sheet. A cheat sheet is indicating that which algorithm you need to use, whether I have to use the supervised or I have to use the unsupervised or reinforcement. So based on your application, you can use this cheat sheet for any application. Based on your application, you can take a decision. Suppose dimensional regression is required. yes, then you have to go for unsupervised. Even unsupervised also, we have a different category. And if it's not required, have a responses, means output is predictable. Then the clustering, unsupervised clustering, here supervised clustering, like that. Different, for each application based on your requirements, you can select. It will lead you to go for a required algorithm. So taxonomy of machine learning. To discover the structure and label data, the clustering algorithm can be used. So, and based on is the requirement based on the data characteristics. Here I have given in the coming slides. A couple of slides will be lead you to. So based on the characteristics of the data, which algorithm is suitable. Right. So the conclusion finally, IoT consists of vast number of different devices that are connected with each other and transmit huge amounts of data. The smart city is the one most important application of IoT and provides various services in domains such as energy, mobility, and urban planning. These services can enhance and optimize by analyzing the smart data collected from these areas. Based on the data characteristics, you can select any one of the machine learning algorithm and then use that algorithm to improve or to extract the knowledge from the collected data. Many data analysis algorithms can be applied. Based on these characteristics, use the algorithm. After applying the algorithm, you choose the suitable algorithm for specific for IoT. The references, some of the references, data mining, inference, and the prediction by Haskell. And for the fundamentals of machine learning, is goes from this Dura and Hart. Actually, it is a old book, but it has much of the information. So this is about the algorithms. What are the algorithms we have, and what based on the data types, we have to choose the algorithm and apply it and analyze the data. Yeah. Thank you, sir. With this, I will stop because have the given time is only 11:30. Still, I have taken some more time. Okay. If you have any queries and all, you can use my mail ID. I am typing my mail ID in the chat box. Srinu.begin@nitw.ac.in. This is my mail ID. You can contact me at any through mail at any time, so that I will give the clarification for your doubts and all. Thank you, sir. Thank you, Comrade Garu, for giving me the opportunity to give some information about the machine learning and its IoT application. Thank you, sir.
Dr. Biken Garu, shall we take one or two questions? Then.
Yeah, sure.
I request participants who have any query, any questions, please raise your hand, or you may put your question in chat box. If anyone wants to make any query, please.
The fault analysis in AWS and wireless sensor networks, right? So wireless sensor networks, in the fault analysis, generally you can apply the supervised FVM model is a better the model. Still, already you see the recent journals in IEEE, some machine learning applications in WSN. That is that will give you the more information about the machine learning.
One more question, please. Anyone? One more question. We will allow you. Sir, have you
implemented ML for IoT applications on FPGA. We are working on it. We have taken a pink board and we are trying. Still, it's not completed. We are working for the coding unit in HEVC. So in HEVC, there is a coding unit. The optimization of coding unit using machine learning, SVM techniques we are using. We are now working on it. Still is not completed, but there is the huge scope implementation on FPGA.
Okay, Dr. BK Srinivas garu, thank you very much for delivered a talk for our all participants in 5-day ATAL FDP. It is you are narrated very well how IoT is linked with machine learning. So thank you so much. On behalf of organizing committee and on behalf of participants, we will cordially invite you to participate in valedictory session at 3:30 p.m.
Thank you, sir.
Okay.
Definitely.
Thank you, Dr. BK garu.
Thank you all. Thanks to all the participants. Thank you.
Thank you. Now I request Mr. Rishendra Babu, Assistant Professor of EC Department, Good Level Engineering College. Please proceed. I request Rishendra Babu garu, please proceed.
Thank you, sir. Good morning, all. Welcome you all to the second session of today's program. It is my privilege to introduce the resource person, Mr. Ramakrishnan Dutt. Mr. Ramakrishnan Dutt did his MTech in JNTU-K, Kakinada. He has an overall experience of more than 10 years together in academic and industry. Currently, he is working as staff software engineer, embedded systems in Enphase Solar Energy, Bangalore. He is currently working on developing and automating embedded APIs for solar-based gateway product that has complete solution for rooftop-based solar inverter, where the project involves converting DC to AC using inverters, transforming data from inverters to local gateway, transport local gateway data to cloud interface. He has visited the USA, New Zealand, Singapore on official visits for making design requirements of the projects. He is also the life member of IST. I thank all the members who are present here. Now I welcome Mr. Ramakrishnan Dutt to continue the session. Thank you, sir. Thank you, one and all.
Hello.
Hello, sir.
Yeah. Thanks for introducing me.
Thank you, sir.
Okay.
Thank you, Rishendra Babu garu.
1 minute. Sir, are you seeing my screen?
Yes, sir, visible, sir.
Okay. Because my system didn't allow.
Ramakrishna Datta garu,
Yeah.
1 minute.
Yeah.